Good afternoon, or evening, or morning, whenever you're watching this. Today, we would like to look at the quadratic formula, how to derive it from the basic quadratic form. Now, the quadratic formula is infinitely useful in regards to solving quadratic equations. It gives us the roots every time, whether it's complex, real, um, however the solutions manifest, that quadratic formula always gives it to us. But how do we derive the quadratic formula? The answer to that comes from the idea of completing the square. So in your algebra class, and I'm probably going to do a separate video on completing the square, let's take some quadratic. And we see it's in the typical form, ax²+bx+c equal to 0. You should always have it equal to 0. Sometimes you might be missing a b term or a c term, but you always have the x squared term. That's where we get the idea of the quadratic. It's the fact that the highest power of a variable is squared, so that's quadratic. So if I want to solve this, I can use what's called completing the square. And the first thing I'm going to do is I'm going to move 3 over to the right. So I'm going to add 3 to both sides. We get x squared plus 2x equals 3. Now, to complete the square, and the name is telling us what we're going to do. We're going to add a term to the left-hand side, and we'll have to add it to the right-hand side as well. But we had it to the left-hand side. It will allow us to factor the left hand into 2 binomials that are the same, meaning that they're square. So we're completing the square is finding the term that will allow us to do this. So what we do is we take half of the b term, and b here is this. Remember, here's a, and c we moved over. So we want to take half of the a term, or b term, which is 2, and square it. So basically, we have 1/2 times 2 over 1 squared, which is 2 over 2 squared, which is 1 squared, which is 1. So that's the first thing we do. We find that term, and then we add it to both sides. I'm going to take x squared plus 2x plus 1 equals 3 plus 1. All right, so why do we do that? Now we have a more complicated quadratic equation. Well, we did it so we can have a square on the left-hand side. And if you notice, if I factor this, and this will always be true, this is why we do completing the squared. I need 2 terms that multiply to give me 1, and when I add them, give me 2. It's always going to be the number I had before I squared. In this case, we had 1 squared, so 1 squared is 1. But in any other instance, it would be, say we had 2, and we had 2 squared equals 4, and we added 4 to both sides. When I factored it, I would just have the 2. And this allows us to write the left-hand side then as a square. So we completed the square in order for us to come up with this binomial squared equals 4. Now we apply what's called the square root property. You could also call it the nth root property. The idea is that if I have something that's squared, so let's say we have x squared, if I want to eliminate the square, I take the root. So if it's a square, I take the square root of x squared is always x. This is a property of exponents. If I have x to the third and I want to get rid of the third, I take the cube root of x cubed, and that equals x. So no matter what the power is, or I take the root of that power. So in other words, the nth power, I would take the nth root, and that would always equal x. So an aside, in an algebra series videos, I might do some exponent rules and root rules. All right, so I want to take the square root of both sides. Now I'm taking the square root of 4, but anytime I have a root that's positive, even, I want to take the plus and minus of the right-hand side. So in other words, if I had something to the fourth and I took the fourth root, then I would have to take plus or minus on the right-hand side, the fourth root. But we're just dealing with quadratics today, so this is always be true when we're doing the square root property on a square. So the property here tells me that if I take the square root of a square, I get x plus 1. And then we know what the square root of 4 is, it's 2. So we get plus or minus 2. So now we have essentially two different possibilities. We have x plus 1 equals 2, or x plus 1 equals negative 2. Solving by subtracting 1 from both sides, we get x equals 1. Subtracting 1 from both sides, we get x equals 3. All right, so we completed the square to find the roots or the x values of this equation. And we did so by doing something called completing the square. Now, the completing the square method of solving quadratics, in my opinion, is the worst way to solve quadratic equations. The best way is to use the quadratic formula. Now, the quadratic formula, however, is derived from completing the square. So it is not too terrible after all. So here is a quadratic ax² plus bx plus c. Now, a, b, and c can be any number. So we want to derive the quadratic formula. In other words, we want to solve this quadratic equation for any a, b, and c. We want to know what x is. So we're going to apply the complete the square. Complete the square. The first thing we need to do is we're going to get the coefficient of x squared to be 1. So a could be 1, but we're saying a is variable. It's constant, but it could be anything other than 1. So we're not going to assume it's 1. So then I'm going to divide everything by a to get that x squared to be 1, the coefficient. So this becomes x squared. And I'm going to write this way. So we can see b over a is the coefficient of x. And then we have c over a. And 0 divided by anything is still 0. So now we got this simplified form. And we're going to find the term that we're going to add to both sides by taking half of the x coefficient. And this is generally how we do complete the square, right? These steps apply to completing the square. So I'm taking half of the x coefficient. The x coefficient is b over a. So I'm going to multiply that by 2. It's the same as dividing by 2 or taking half of it. And then we're going to square it. So this becomes b over 2a squared. Okay, so complete the square. We want the form to be ax squared plus bx equals c. In other words, we're getting the c to the right. And since we've divided everything by a, it should look more like this. That's what we want. So we're going to subtract c over a from both sides. So when we have x squared plus b over ax equals negative c over a. So to complete the square rule says we're going to add b over 2a squared to both sides. So we're taking this term and adding it. X squared plus b over a x plus b over 2a squared equals negative c over a plus b over 2a squared. Okay. So we did this, again, complete the square. So on the left-hand side, we can write this as a factorization of this polynomial here, or this quadratic, which will always be x plus the term before we square it. So it's going to be b over 2a squared. So this is the factorization. Then on the right-hand side, we're going to write this. Let's write it like this. Let's write it as b squared over 4a squared. So you should start to see the beginnings of some of the terms in the quadratic formula. So now let's do some algebra. Let's add on the left-hand side. I'm sorry, the right-hand side. Add the terms. We're going to add these two terms. So to add negative ca and b squared over 4a squared, we need a common denominator. So the first term has a, the second term has 4 times a squared. So to get a common denominator, I need to multiply this term, that's c over a negative, by a 4 and an a. Because that will give us 4a squared. Now we're adding b squared over 4a squared. And when we add this, we get 4a plus b squared. I forgot the c, didn't we? Negative. So we get negative 4ac divided by 4a squared. Okay, so let's bring the left-hand side down. So let me have x plus b over 2a squared is equal to negative 4ac plus b squared divided by 4a squared. All right, so again, it looks like we're making a bigger mess of stuff, but we're actually simplifying. Now we're going to use a square root property. And if the professor ever asks you, or your teacher in high school, to derive this, they might want to know what properties you're using. So sometimes on the right, it's handy to write, I'm using this here. Or if you want to formalize this in a proof, you would also indicate that by the square root property, I can do the following. So I'm going to take the square root of both sides. Remember, plus or minus on the right-hand side, we have negative 4ac plus b squared divided by 4a squared. This effectively undoes the square on the left-hand side, so then we get x plus b over 2a equals plus or minus. Now, I can think of this as a fraction of square roots, so negative 4ac plus b squared divided by the square root of 4a squared. This is a property that says if I have a division of roots, so the square root of x divided by y is the exact same thing as the square root of x divided by the square root of y. The same is true for multiplication. The square root of x times y is equal to the square root of x times the square root of y. So we're just applying that principle. The reason we're doing that is because now the square root of 2 is 2, and we know that anything squared, a squared, the square root of becomes itself. So in other words, this becomes 2a. And on top, let's write it's this way, b squared minus 4ac. Okay, so this should start to look familiar. So we're going to subtract b over 2a from both sides. I'll write it here this way, which leaves us with x equals negative b over 2a plus or minus the square root of b squared minus 4ac divided by 2a. Simplify the right-hand side. We all have a common denominator of 2a, so we can just write it that way. So we have negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. And this formula, x equals, solves this equation for any a, b, and c as long as a is non-zero. So a can't be equal to 0, little caveat. And that's the quadratic formula. So we derived it by completing the square on that form, ax² plus bx plus c equals 0. And now we have a nice formula that solves any quadratic equation. You'll notice that this is nice and handy and neat. And if you were to try to derive x to the third or x to the fourth or x to the fifth, trying to find a general formula like this quadratic formula, you'll run into complications. But that's best left for a different video. That's it for now. Hope this helped. Please like and subscribe and all that other great stuff. And let me know in the comments if there's another video you would like to see, or if you need any further explanation of this. That's it. Have a great day.